In a normal distribution, 31% of items are under 45 and 8% of items are over 64. Find the mean and standard deviation of the distribution. We have the normal variate z equals x minus x bar upon sigma. If you give x equals x bar in this equation, you obtain z equals x bar minus x bar upon sigma. Therefore, the axis of symmetry of the normal curve x equals x bar can also be notated using z equals 0. Since 31% lie under 45 and 8% lie over 64. In order to evaluate percentage of items lying between x equals 45 and x equals 64, we have to evaluate total percentage 100 minus 31 plus 8, which equals 100 minus 39, which equals 61%. Therefore, you have to maintain this much gap of 61% of items that lie between x equals 45 and x equals 64. Since 31% lie under 45, you have to shade the region to the left of marking x equals 45. Since 8% lie over 64, you have to shade the region to the right of marking x equals 64. If you define z equals z1 equals 45 minus x bar upon sigma, you can mark z equals z1 at x equals 45. If you define z equals z2 equals 64 minus x bar upon sigma, you can mark z equals z2 at x equals 64. Now let us evaluate percentage of items lying between z equals 0 and z equals z1. We have area under the curve to the left and right of axis of symmetry will be equal. We have integral 0 to positive infinity 5 of z dz equals 0.5 and integral negative infinity to 0 5 of z dz also equals 0.5. And we have the total probability equals 0.5 plus 0.5, which equals 1. Since we are aware about the area from negative infinity to 0 equals 0.5, and we have already been given the information, area under the curve from negative infinity to z equals z1 equals 0.31. In order to find out area under the curve from z1 to 0, we just have to take 0.5 minus 0.31, which equals 0.19. Or you can consider, since to the left of axis of symmetry 50% of items are marked and here you have 31%. So between these 2 points z equals 0 and z equals z1, you have 50% minus 31% equals 19% of items marked between z equals 0 and z equals z1. So 0.19 is the probability value for integral z1 to 0.5 z dz. Notice that the shaded region is to the left of axis of symmetry, or we have this region from z1 to 0 is to the left of axis of symmetry. Therefore, to the value of z1 you have to assign a negative sign. The probability value 0.19 lies here. Therefore, the value of z equals z1 is 0.5. Since z1 lies to the left of axis of symmetry, we have z1 equals negative 0.5.